video, I am going to discuss the following marginal revenue problem. We are given a price-demand equation, x equals 400 minus 10 times the square root of p plus 25. So this equation tells us, let's say we're selling widgets, that if we set the price of the widget to something, we are going to be able to sell more or less of the item. So this would be a standard way for a price-demand equation to be written. Now we're going to jump to the end here and try to understand what we're trying to do. This is a marginal revenue equation, and we're trying to figure out how much revenue you will make or lose by increasing production from 200 to 210 widgets. So we need to find the marginal revenue. The point here in this equation, it's often hard to write down the revenue equation explicitly. Especially here we could, because we could do some manipulation, but generally one can't write down the revenue equation explicitly, but that does not prevent us from finding the marginal revenue equation. So the first thing we're going to do in this problem is find the rate of change of the price with respect to x. We want to find the derivative of p. So we're going to use implicit differentiation. So let me do that on another tab. So our function is x equals 400 minus 10 square root of p plus 25. And I want to implicitly differentiate this. So my variable here is x. So when I take the derivative, I'm going to get 1 equals, the derivative of 400 is 0. We get a minus 10 p plus 25 to the minus 1/2. We forgot the 1/2, so we'll put the 1/2 in here. 1/2 p plus 25 to the minus 1/2 times the derivative of p, which is p prime. So we can solve for p prime as we've got a -5, so -1/5 p plus 25 to the 1/2. So that is our derivative of p with respect to x. Now let's think about our revenue. Our revenues is going to be p times x, right? The price times the quantity we sell. So the marginal revenue is, this is going to be our product rule, p prime times x plus the derivative of p times the derivative of the second, which is 1. Okay, so that's our marginal revenue. And we are trying to calculate the change, the approximate change in revenue, which is going to be dr, which is going to be r prime of x times dx. And x is 200 and dx is 10. Okay, so in order to do this, we need to find r prime of x. We know x, so what we said, x is 200. So we need to figure out what p is when x is 200, and we need to find out what p prime is when x is 200, and then we can multiply out our r prime equation. So we've got to find p and p prime when x equals 200. All right, let's find p. So we know 200 equals 400 minus 10 times the square root of p plus 25. So we take the 10p plus square root of p plus 25 to one side, we take the 200 to the other side, and we end up with 10 square root of p plus 25 equals 200. Divide both sides by 10, and we get the square root of p plus 25 equals 20. square both sides. P plus 25 equals 400, so P equals 375. So there's P. And then we want to find P prime. P prime is negative 1/5 P plus 25 to the 1/2. When x equals 200, P equals 375. So we can plug that into this formula. We get P prime equals negative 1/5. 375 plus 25 is 400 to the power 1/2, which means P prime equals negative 20 over 5 equals negative 4. Okay, so now we can go over here. We've got to find R prime. So R prime equals P prime X times plus P. So P prime, negative 4 times X, which is 200, plus 375. So that's negative 800 plus 375 is negative 425. So now we're ready to plug into our equation. The change in revenue is R prime of X. R prime of 200 is negative 425. dx is 10. So if we increase production, negative 4,250. If we increase production from 200 to 210, we lose 4,250, which suggests we should not increase production. So this problem is exactly like any other marginal revenue problem, except that the derivative is slightly harder to take because you have to use implicit differentiation.